In the heart of the Negev, where rain is a rumor and crops wither, giant tanks brim with tropical fish, species meant for tropical rivers, not endless sand. This isn't science fiction. Israel pulls ancient, nearly undrinkable water from 700 meters below and flips it into gold, exporting fish from a desert few thought could sustain life. But behind this engineered miracle lies a double problem that should have ended the project before it started: heat and salt. Why risk it all? And how did a barren wasteland become a seafood exporter? In 1975, as Israel's water crisis deepened, a team of geologists and engineers gathered at the edge of the Negev with a question few dared ask: what if the desert itself held a hidden reserve? Their answer would come from drilling nearly 700 meters into the earth, deeper than any local well, farther than the region's farming tradition had ever ventured. The work was slow, the machinery borrowed from oil fields, the risks enormous. Layers of sandstone and limestone gave way to pockets of ancient water, trapped since a time when this land was lush and green. By 1979, after 4 years of uncertainty, the first gush of water surged to the surface. Tests revealed something remarkable. This was fossil water, sealed away for over 100,000 years, untouched by the modern climate. The aquifer's depth and age promised a supply unlike any other in the region. Yet the moment of discovery was complicated by a new uncertainty. The water was real, but its properties, temperature, taste, and salt would soon raise questions that threatened to halt the project before it began. For now, though, the impossible had been proven. The Negev hid an ancient ocean waiting to be put to use. The first gush of water from the deep Negev wells brought more questions than answers. At nearly 40 degrees Celsius, the liquid rising from the ground felt closer to bath water than anything fit for crops or homes. Most plants wilt at these temperatures, and even the hardiest desert species struggle to survive when irrigated with water this hot. But heat was only half the problem. Salinity readings showed salt levels at about 1/10 that of seawater, roughly 3 to 10 times higher than what's safe for drinking. For most conventional crops, this brackish mix is a slow poison, burning roots and stunting growth. Traditional farming methods, whether for wheat, vegetables, or even citrus, simply couldn't handle it. The water's chemistry made it useless for livestock and dangerous for human consumption. Engineers and agronomists faced a double barrier: a supply of water that was both too hot and too salty for any known agricultural system in the region. After years spent drilling and dreaming, the team stood at a crossroads. The Negev's hidden aquifer was real, but every test result seemed to say the same thing: this water wasn't meant for people, and certainly not for farming. The project teetered on the edge of failure, demanding a radical rethink about what, if anything, could thrive in these extreme conditions. Professor Amram Halevai and his colleagues at the Volcani Center looked at the Negev's brackish, hot water and saw not a problem, but a match for life that thrives where others fail. Instead of fighting the water's nature, they asked which fish could use it to their advantage. 3 species stood out: barramundi, tilapia, and sea bass, all known for their ability to handle both heat and salt. In their native habitats, these fish move between rivers and coastal lagoons, adapting easily to changing salinity. In the Negev's tanks, the warmth accelerates their growth, while the mild salinity does something unexpected. It cuts down on parasites that often plague fish in freshwater farms. Records from Aquatech's Negev site show parasite outbreaks dropping to a fraction of what's seen in traditional systems. With each cycle, the team refined their approach, proving that the right biology could transform a liability into an edge. The tanks filled with healthy, fast-growing fish, and the desert began to hum with a new kind of life. In the early 1990s, Negev fish farms faced a turning point. As production scaled up, operators like Yaakov Levi and Gilad Ben David watched ammonia levels in their closed tanks climb to dangerous highs. Dumping water was never an option because every cubic meter pumped from 700 meters underground cost more than 60 cents if it were fresh, and in the desert, waste meant lost profit. Instead, they began channeling the nutrient-rich effluent to nearby olive groves and date palms. The results were impossible to ignore. Olives irrigated with recycled fish water grew up to 20% faster, while the fish themselves converted feed into weight with a 15% efficiency gain. This closed-loop approach did more than solve a waste problem, it created a dual revenue engine. One pipeline of water now supported 2 harvests, fish for export, crops for local markets. By the mid-2000s, Negev farms like Aquatech were producing 2,000 tons of barramundi each year, with much of it shipped to Europe. What began as a workaround for waste had become the financial backbone of desert aquaculture, proving that even in the harshest conditions, the right system could turn every drop into profit. As water scarcity accelerates worldwide, Israel's desert fish farms prove that constraints can spark invention. The next resource revolution may start where everyone else saw only waste. What would you try next?